the centuries-old martial art of Iaido. The hair-splitting precision of the modern industrial robot. Remarkably, it wields a sword with such control and accuracy. It can slice clean through a 1 centimeter thick pea pod along its length. The robot outperforms the most skilled of swordsmen. Yasukawa Electric Corporation is a leading manufacturer of industrial robots that are not only accomplished in the art of swordsmanship, but also are the driving force at the heart of industries around the world. Its latest models are nimble, fast, and extremely precise, capable of accomplishing complex tasks with amazing efficiency and reliability.
It's not only about automation, it's also about having a partner you can trust.
That trust depends on the technology at the core of the company's specialty, servo motors. These highly efficient electric motors are what drive the robot's arms with lightning speed and pinpoint accuracy. In this episode of JTech, we examine the technology developed by one Japanese company whose ideas are revolutionizing the world of industrial robots.
Hello and welcome to the program. I'm Marc Carpentier. Japan is the world leader in industrial robotic technology, accounting for more than half of global shipments. Unlike humanoid robots, which are still largely under development, industrial robots have been around since the 1950s and are used in factories all over the world. They are basically manipulators designed to move materials, parts, and tools and accomplish duties that are dangerous or unsuitable for human workers. The driving systems of industrial robots are mainly of two types, hydraulic and electric. Early industrial robots were hydraulically driven, but today almost all of them are electrically powered, and they are reshaping the manufacturing industry. In this program, we'll be exploring the technology behind one of Japan's leading makers of industrial robots, Yasukawa Electric. But first, let's look at some of the company's latest products.
The city of Kitakyushu in southwestern Japan is a major industrial center. It's home to dozens of major corporations, including Yasukawa Electric. The company is the world's largest manufacturer of AC servo motors and motion control systems. It's also the world's second largest manufacturer of industrial robots, with 300,000 units installed in factories around the world. In 1990, Yasukawa was the first robotics company ever to install an assembly line where robots make robots. It has since been mass-producing industrial robots while pursuing research and improving the technology. Next door to the company's headquarters is a spiffy-looking piece of architecture. It houses a showroom where Yasukawa's latest and future technology is on display for customers and visitors at large to marvel at. Some 50 robots are showcased here.
Hi, Mark.
Nice to meet you, sir.
Nice to meet you. Welcome to Yasukawa Innovation Center.
Thank you very much.
There to greet us is the showroom's director, Kazuo Okabayashi, a 35-year company veteran who is involved in the development of robot control systems.
Okay, I would like to introduce this robot first. This robot we call 7-axis Motoman robot.
The showroom centerpiece is the company's latest industrial robot, and it's the first of its kind in the world. Its movements are swift and smooth as it deftly moves a random set of blue cubes through a complex array of obstacles and sets the cubes down precisely with a delicate touch. It has 7 axes of rotation, mimicking the human arm.
7 means that the human arm, from shoulder to wrist, we have a 7th freedom we have. We want to make same using this robot. Human arm, you can move this elbow to the down or up.
Let's compare the movements of this latest robotic arm with a previous model. On the left is the older model. It has 6 axes of movement. It can pass through the frame, but cannot reach the pink board on the other side. The new model has 7 axes. Its arm can easily pass through the frame and reach the board to scribble the number 7. This clearly demonstrates how the 7th axis greatly improves efficiency.
If this robot used, you can reduce the space or the production line.
I see. So this robot, what it is doing now, would not be possible without that 7th axis.
Yeah, that's right.
The speed and accuracy of Yasukawa's robotic arm depend on core technology that has made the company famous: the servo motors that are built into each of the arm's axes. Unlike standard electric motors, servo motors deliver rotational power and speed that can be accurately controlled. Servo motors are usually coupled with a control system which provides the commands and amplifies the power. Inside the servo motor is a sensor unit that detects rotational velocity and feeds that information back to the controller, which in turn tells the motor to start and stop at precise and designated positions. Here's how it works. Inside the unit is a disc with tiny perforations around the rim. The position of each hole is predetermined and stored in the control system's memory. A sensor on one side detects when a light beam coming from the other side passes through the hole. The data received from the sensor lets the system know the exact position of the disc.
This latest motor can detect 1/16 millionth of a rotation.
A motor capable of stopping within 1/16 millionth of a rotation was unprecedented. This ability to control the servo motor with such extreme precision is what makes the robot go fast, smooth, and accurately.
Okay, we try to make each color one.
Okay.
Okay.
Okabayashi has taken me to a booth where 6 small robotic arms work in sync to make mini cars.
Now that's robot.
Input the color and number of mini cars you want to make, and away it goes.
Oh my goodness. That must have been about 10 seconds?
Ah, close. 9 seconds.
9 seconds. That is amazing.
The perfectly functioning assembly line occupies a space less than 5 meters square, a boon for small factories with limited space.
The secret behind these highly efficient robots is the drive mechanism, basically servo motors coupled with a computerized control system. Today, all of Yasukawa's robots use servo motors. Yasukawa began developing these high-performance drives in the late 1950s, but not for making robots. As we're about to see, the company had other motives.
Yasukawa Electric was founded in 1915 by a coal mining company in Kyushu called Yasukawa Zaibatsu. Initially, it aimed to manufacture a comprehensive line of heavy machinery, but major players such as Hitachi and General Motors were too big to compete against, so the company chose to narrow its focus on the development of electric motors. Its main products were motors for pumps and motorized winches used in coal mines, as well as transformers for controlling motor speed. Reconstruction after World War II spurred economic growth and progress in the mechanization of industries in Japan. This led to a rise in demand for electric motors. This is a motor from the 1950s developed by Yasukawa. It came with a speed controller and was used in printing presses. However, it took time to reach full speed and was slow to decelerate when switching it off. All of the company's motors functioned similarly. Yasukawa's management thought that since markets were increasingly dependent on productivity, more efficient motors were needed. So the company decided to create a completely new type of motor. It was one that could start and stop more quickly, as well as be controlled for speed and torque. Teruyuki Fukuda was put in charge of developing the new motor. He hadn't a clue where to start, so he re-examined the design of the company's base models. Here's a simplified explanation of how an electric motor works. Embedded within a frame called a stator are magnets with opposing poles, N for north and S for south. When an electric current is passed through the coil surrounding the rotor placed between the magnets, an electromagnetic force is generated, causing the rotor to turn in one direction, depending on the flow of the current. The greater the electricity flowing through the magnets, the stronger the electromagnetic force and the faster the rotor turns. Yasukawa motors had coils embedded in the rotor. The gaps between the coils interfered with the smooth flow of the electromagnetic force. Fukuda thought he might be able to improve on the motor's efficiency by increasing the number of coils embedded within the rotor and narrow the gap between them, but trials led only to more errors. Until one day, when bathing his daughter, Fukuda had a eureka moment. She had drawn a plum blossom on the foggy bathroom window. The simple drawing triggered Fukuda's imagination. He realized that if the coils were positioned on the surface of the rotor like flower petals, then they could be juxtaposed without any gaps, creating greater magnetic flux and resulting in more power. What's more is that since there is no need to insert a coil inside the rotor, the diameter of the rotor could be made smaller. As a result, the inertia caused by the rotation would be suppressed, making the motor stop more quickly. Quicker response meant more control over the motor's function. In 1958, he successfully produced a new type of motor that could respond to activation and shutdown instructions 100 times faster than existing standard designs. Rotational acceleration was also dramatically improved, greatly increasing power. This motor design is the basis for Yasukawa's high-precision servo motors. In the 1960s, Yasukawa Electric applied these new motors in the development of its automated assembly lines and pipe welding machines used at its own factories and ironworks. After further refinement, the company successfully commercialized its new motor, calling it the Cup motor.
The servo motor was a revolutionary invention and solidified Yasukawa's reputation as a leading manufacturer of industrial motors. But the concept of using these motors in robots still didn't exist, for the simple reason that industrial robots hadn't been invented yet. It was only in 1961 that American inventor George Devol and engineer Joseph Engelberger created the Unimate, the world's first industrial robot. The Unimate was a hydraulically driven device and was used for welding on General Motors assembly lines. In 1967, American-made industrial robots were showcased at a trade fair in Tokyo. The following year, Kawasaki Heavy Industries gained a license to produce Unimate robots in Japan. Yasukawa predicted that factory automation would accelerate and decided that it too would enter the robot business. Robotics was still a fledgling market and competition was going to be challenging. But the company had an ace up its sleeve. It had technology other companies in Japan didn't have, the most advanced servo motors in the country. Yasukawa would make history by becoming the first Japanese company ever to produce servo motor-driven industrial robots and outpace world production of hydraulic robots.
In 1971, Yasukawa started prototyping a robot based on the improved motors it was using in its factory automation systems. To control the robot's movements, it developed a computer system into which coordinates could be input via an interface called a pendant. 3 years later, in 1974, their first prototype was showcased at an international robotics exhibition in Tokyo. The robot could move horizontally and vertically and rotate the tip of its arm. Different tools could be attached to the arm for different tasks, such as welding and handling loads of up to 15 kilograms. It was clever, but it had a major flaw. Its servo motors were not powerful enough, making it too slow for factory automation. It was Japan's first ever all-electric robotic arm. It attracted a lot of attention, but took no buyers. News came from overseas that a manufacturer in Europe had succeeded in commercializing an all-electric industrial robot. ASEA was a long-standing Swedish company founded in 1883. It specialized in the development of generators and power transmission systems. Yasukawa engineers studied the robot's specs. The IRB-6 had a 5-axis arm with 5 servo motors installed in its base. Though the motors were weak, the arm moved smoothly and quickly. Its unique structural design surprised Yasukawa engineers. Yasukawa contacted ASEA, suggesting they form a partnership. But negotiations fell apart when the two sides failed to agree on the terms, prompting Yasukawa to go it alone in developing a multi-axis robot. It took a year for Yasukawa to complete a prototype. It was called Motoman L30. Its arm could be fitted with different tools and was designed for either welding or transporting loads of up to 30 kilograms. In keeping with ASEA's robot design, engineers placed the motors in the arm's base. A combination of steel rods and pulley systems inside the arm transferred power from the motors to the arm's axes and tool coupling at the tip. The robot was put to vigorous testing for 3 full months. During that time, it had managed to work properly for just 2 hours. The steel rods inside the arm could not support the arm's own weight and soon snapped. To solve this problem, the engineers called on motor expert Takeo Suzuki, who had majored in mechanical engineering at Tokyo Denki University. Suzuki had a rare talent for calculation and was known for thinking out of the box.
We made a prototype that could move masses of 15, 20, and 30 kilos. But we needed a robot that could also weld. I wondered how that could be possible.
Suzuki first suggested to focus on developing a robot for welding only. Since it wouldn't have to move things around, its lifting capacity could be reduced to 10 kilograms. Smaller motors could be used, and the height of the robot could also be brought down from 1.8 to just over 1.4 meters. But testing revealed a problem. The motive power did not transmit properly to the tip of the arm. Movement of the arm could not be controlled accurately. Precise movements were a must for welding. Suzuki replaced the steel rods with belts. However, they easily got misaligned and elongated over time, losing accuracy once more. One evening, Suzuki caught sight of a security guard pushing a bicycle with a slipped chain. He realized that unless it comes off completely, a chain always maintains its position on the other cog. So he tried chains instead of belts. But they too would stretch and slack with repeated use, the result of wear on the linchpins holding the chain together. Then he thought of adding springs within the chain links. Any slack in the chain would be taken out by the springs. It was a brilliant idea and led to the launch in January 1977 of the company's flagship product and Japan's first commercially produced all-electric welding robot, the Motoman L10. The first client to purchase the new robot was an auto parts manufacturer specialized in suspension systems. The company replaced all its hydraulic welding robots with the Motoman because of its accuracy. Shigeki Harada was in charge of welding at the company. He recalls how impressed he was with the Motoman's performance.
The accuracy of a hydraulic robot stopping position was only to within 5 millimeters. But with the Motoman all-electric robot, it was 1 millimeter. It moved exactly as we wanted it to. The result of the electric robot was so precise, we decided to use Motoman L10.
The Motoman L10 gained a strong reputation as a highly precise welding robot and went on to sell 1,700 units.
From the mid-1980s onwards, the semiconductor business in Japan developed rapidly, greatly increasing the demand for small, high-precision motors for precision machinery. Yasukawa got to work on developing even more accurate and compact motors. The smaller motors would change how robots were designed. Until then, the motors in the company's robots were installed at the base of the arm and indirectly transferred power to the tip via an array of rods, belts, chains, and pulleys. The miniaturization of the servo motor changed all that, making it possible to install the motors right at the axis points of the arm. This configuration, called direct drive, greatly enhanced performance. Industrial robots at the time had 5 axes. By adding a 6th axis, Yasukawa robots demonstrated greater freedom of movement. Word about these highly efficient robots spread, and the company began receiving orders to develop custom-made robots for manufacturers, starting with the automotive industry.
In 1998, Honda ordered a huge number of robots from 2 major Japanese manufacturers as it moved to modernize its production lines. One of those companies was Yasukawa. Honda had previously built its own production line robots in-house, but its new lines were to be more compact and needed robots that could multitask on multiple models on the same line. Honda figured it would be more cost-effective to develop the new robots in cooperation with other manufacturers. So it teamed up with Yasukawa to harness the company's unique servo motors and control systems. For Yasukawa, this was a huge business opportunity. The man tasked to lead the development project was Masahiro Ogawa.
Making a production line more compact while increasing versatility are incompatible concepts. If you want to accomplish more tasks, you need more space. It's difficult to have both at the same time.
The most challenging of Honda's requirements was a new line for welding side panels onto the vehicle body. At a welding station on a production line, there were 10 robots per vehicle, 5 on each side. The new plan combined 2 stations into one, involving 20 robots per vehicle, 10 on each side. This was completely impossible with the existing robots. Ogawa had to design a new type of robot that could squeeze into a much tighter space.
With a standard 6-axis robot, the arm turns around the pivot point, and it needs vertical space to extend and retract. So we created a sliding axis that moves back and forth instead of pivoting.
Here's the robot Ogawa designed. It's fixed to the wall, not to the floor. It has 2 arms set one above the other. It has compact servo motors Yasukawa had developed back in '92. Called the Sigma, the motor is 2/3 smaller than the previous models. Since the arms work only on their designated level, there's no need for them to move vertically. And because the motors are small, the arms are as well. Ogawa's design made it possible to place 10 robotic arms side by side at a station on a production line, just as required by Honda.
Because of the motor's small size, we could arrange many of them in various places on the robot. This allowed us to create many different designs.
At Honda's Sayama car factory in Saitama Prefecture, just north of Tokyo, 900 vehicles roll off the factory line each day, thanks to Yasukawa's multi-arm robots. Robotic arms extend outward from the walls on either side of the station, simultaneously welding panels to both sides of the car body. The robot completes the job in only 45 seconds.
Other manufacturers weren't able to produce custom-made robots like these. Our robots have to be able to contact hard-to-reach places of the vehicle body. So we worked together with Yasukawa.
Yasukawa delivered 1,600 robots to Honda, not only for welding, but also for painting and handling. Based on what it had learned during its partnership with Honda, Yasukawa was able to spin off technology to make several other kinds of robots, including transport systems for LCD panels and semiconductors. In fiscal 2003, the company shipped in excess of 10,000 robots, a world record among robot manufacturers. Today, Yasukawa Electric is also a player in the pharmaceutical industry, where robots are more efficient than humans when making new drugs. This robot's control system is easy to use. It can perform more than 50 different tasks, including adding and mixing reagents to produce chemical reactions. When appropriate times and quantities are input into the commands, The robot conducts the experiment as instructed in the designated order and with extreme precision. It's not necessary to reprogram a command sequence each time. The control system determines how a series of commands should link. Now the company is developing control systems that do not require expert knowledge. The control system on this robot prevents accidents in places where people have to share their workspace with a robot.
What makes this robot safe?
This robot has sensors in each joint. The sensors will work when they feel a counteracting force, like this, for example. If a person should collide with it, it stops.
In Japan, as in many other countries, the law stipulates that to avoid injury, robots must operate inside a safety fence. An industrial robot will follow its commands and move with determined speed and force until it receives the instruction to stop. If a human enters the robot's operating sphere, there's great danger that they'll be struck forcefully and repeatedly. However, robots like this one, with its sensors and ability to stop automatically, eliminate the need for a safety fence. This particular robot can be programmed manually without the assistance of a technician, making it very easy to use. The user moves the arm to each position in a sequence and enters a simple command at each point. The robot is designed for use in crowded workplaces where people have little or no robotics experience, or in places where the nature of the required tasks changes frequently.
Very impressive. As industrial robots continue to evolve, they will play an ever greater role in making our factories more efficient, our working environments safer, and the products we purchase of higher quality. Thanks to the inventive minds of engineers like those at Yasukawa Electric, robots will increasingly become our trusted companions, helping us to achieve our fullest potential and realize the world of our dreams. I'm Marc Carpentier. Thank you for watching. See you again next time on JTech. Bye for now.